All right, so we're going to finish up chapter 23, and then we will review for the test on Thursday. All right. So we left off at the ethers. All right, so you have water, which has an oxygen between two H's. Then you have your alcohol, which has an oxygen between a carbon group and a hydrogen. And then you have an ether, which is an oxygen between two carbon groups. All right, so when you name an ether, there's going to be two ways that we're going to name it. One is going to be alkyl, and then ether. That's the way I'm expecting it, but I'm going to also teach the Upac method as well. Your alcohols. We're going to talk about some reactions that we're going to do with our alcohols. All right, so I'm going to start with oxidation reduction of alcohols. Although we're not going to do really reduction of alcohols, but we're going to do oxidation of alcohols, get the products, and then the reverse reaction is the reduction of those products to go back to your alcohol. All right, so I'm going to start with ethanol. So CH3, CH2OH. All right, and so we see that this carbon that connects to the OH is bonded to one other carbon. All right, and so this reaction is going to be correct for any primary alcohols. All right, so if we oxidize a primary alcohol, the way you're going to see oxidation, you're either going to have an O in brackets. So an O in brackets indicates that you have added an oxidizing agent. All right, they could also list an actual oxidizing agent. The most common one is a dichromate, Cr2O7 - 2, and that is usually in acid. H2SO4 is the usual combination of a dichromate and sulfuric acid. There are other oxidizing agents. This is one of the more common oxidizing agents for organic chemistry. All right, so when we do an oxidation reduction, we have different definitions. So when we do an oxidation, that means that we are adding oxygen or removing hydrogen. All right, and so if we're doing reduction, it is the opposite of that. We are going to remove oxygen, or we're going to add hydrogen. All right, so when we oxidize our alcohol, the first oxidation, and we're going to have two of them for primary alcohols, is to form this compound. All right, and so we go from an alcohol and then we oxidize it, and now we have an aldehyde. And so this alcohol is ethanol. You don't need the 1 because there's no such thing as a 2-ethanol. All right, and so this is ethanol. This is your aldehyde. So when you oxidize a primary alcohol, you get an aldehyde. Now you can further oxidize it. So do a second oxidation, and we get this compound. And this one, we see that that is a bond. All right, so we see that we have a carboxylic acid. So when you oxidize an aldehyde, Or if you oxidize a primary alcohol, you can get a carboxylic acid. So an aldehyde will be oxidized into a carboxylic acid. A primary alcohol, you'll either get the aldehyde, and you can stop there. There are ways to stop at the aldehyde, or it can continue and give the carboxylic acid. All right. So if we look and see what's happening, if we look at just the molecular formula, we see that our ethanol has 2 carbons, 6 hydrogens, and 1 oxygen. So if we just had the number of carbons, which is 2, hydrogens, which is 6, oxygens, which is 1, that is your molecular formula. Now when you look at the product, the aldehyde, we still have our 2 carbons, but now we only have 4 hydrogens, and we still have our 1 oxygen. And so the definition for oxidation for step 1 was we went from 6 hydrogens down to 4 hydrogens. And so oxidation is removing hydrogens. So this one has removed 2 hydrogens, and that is the definition of oxidation for step 1. If we then further oxidize our aldehyde from C2H4O, now our carboxylic acid here is C2H4, and now it is O2. So this definition was we had 1 oxygen, now we have 2 oxygens. So we added oxygen. And so this first example of a primary alcohol oxidizing to an aldehyde, then oxidizing to a carboxylic acid, is both of those possibilities. The first step was removing hydrogens. The second one was adding oxygen. Both of those are oxidation. All right. So now if we go in the reverse direction, so now I'm going to show my arrow going from here to here. Now we're going in the reverse direction. What we write in brackets is an H. So your H in brackets indicates a reducing agent. The most common reducing agent is going to be a sodium borohydride, NaBH4. Or another very common reducing agent is lithium aluminum hydride. So lithium aluminum hydride is also a very common reducing agent. So you'll see an H on the arrow, or you will see a sodium borohydride or lithium aluminum hydride, indicating that you are going to reduce your compound. So here, same thing. When we go from our aldehyde down to our alcohol, an aldehyde goes to not just any alcohol, it goes to a primary alcohol, and that is, of course, reduction. So again, you can look at it in reverse. Here we have our carboxylic acid that has C2H4O2. Here we have C2H4O. And so the first reduction was removing an oxygen. The second reduction, we went from C2H4O to C2H6O. The second one was the reduction of adding hydrogen. All right, so you need to know your definitions for oxidation reduction in organic chemistry, and that is about oxidation, adding oxygen or removing hydrogen, reduction, remove oxygen, add hydrogen. You can count the electrons, you can do all that. It is not normally done in organic. It is just, here's the organic reactant, here's the organic product. All right, now if we do a secondary alcohol, now when we oxidize it, we get a ketone. All right, so a secondary alcohol, and so the simplest secondary alcohol would be isopropyl alcohol. So here's your secondary alcohol, and it will be oxidized into a ketone. In this case, it is acetone. All right, and so your isopropyl alcohol, which is a secondary alcohol, will be oxidized to a ketone, and the name of this ketone is acetone. All right, and so, or of course, propanone, 2-propanone, or dimethyl ketone. But everyone calls that acetone. Now, that's it. That's all it goes to a ketone, and then it stops. If you try a tertiary alcohol and you add an oxidizing agent, you get no reaction. You cannot oxidize a tertiary alcohol. And so oxidation is very fast. When you have a primary alcohol, it will go to the aldehyde. The aldehyde will then go to a carboxylic acid. Secondary alcohol will oxidize to a ketone. A tertiary alcohol will not undergo oxidation. All right, so here is an ether, and here's the Upac name of the ether. All right, and so we're going to give the common name, and then I will show you how you get the Upac name. All right, so the common name is on each side of the O, you got to name the group. On this side, you've got methyl, so CH3 is methyl. On the other side, you got 3 carbons, that's propyl. And so you put it in alphabetical order, you've got methyl propyl ether. So that is the name, methyl propyl ether. Now, I would also, so that's full credit, or if you put N-propyl, of course, that's full credit, because there is a difference in your propyl. You have N-propyl, you have isopropyl. If it is just said propyl, then you're going to go with the straight chain. If it says N-propyl, there's a 100% chance that's exactly what that means. All right. So the Upac name always starts with finding the longest carbon chain. So the longest carbon chain here is 1, 2, 3. And that is your base name. So it is propane. And then off of carbon number 1, of course, you could number it the other way, but then it would come off of carbon number 3. You want the groups to be on the smallest numbers possible. So you always number your carbons closest to your substituted group. All right, so 1, and on number 1, we have a methyl with oxygen. And so the way we name a alkyl group with an oxygen is an alkoxy. So we're always going to call this an alkoxy. So since this is methyl, it is a methoxy. And then you have to put the number. You put the number 1 methoxypropane. The reason why you have to put the number 1 is because I could have drawn this CH3O, and then I could have put my CH here and a CH3 and a CH3. And if I did this and I did the Upac name, 1, 2, 3 is my longest carbon chain. All right, and so that is a propane. Now you see that your methoxy is still coming off of this chain, but it's coming off of carbon number 2. So this is a 2-methoxy propane. If you're not sure if you have to put the 1, if there is such thing as a 2, then you must put the 1. When in doubt, always put the numbers. If you're putting the number and it doesn't have to be there, I don't take off. If you do not put the number, like in the case here, if you just said methoxypropane and now you got a 50-50 chance, which one is it, you're going to lose many points. All right, so I would go ahead and put the numbers. If in any doubt, put the number. All right, so now the common name, what the name I'm expecting for this one is methyl, and then on this side it is isopropyl, and I would accept either order for alphabetical order. But when you use the iso, tertiary, secondary, those you use the alphabetical order. When you're using di, tri, tetra, you do not use those for your alphabetical order. And so the correct name here would be your isopropyl methyl ether. But I would accept it either way, because if you're saying I'm putting the methyl first because that's a propyl group, that's fine. But when you're doing common names, the letters do count as the alphabetical order. So this is I coming before M, isopropyl methyl ether. All right, so here we have an alcohol. So here's the functional group. It is a hydroxy group. That tells me that I have an alcohol. I see that the carbon attached to that hydroxy group is connected to 3 other carbons, so I know that that is a tertiary alcohol. All right, and so I'm going to give the name. This one has to have the longest carbon chain, and I want the lowest number for the group, for the carbon that has the OH group. And so I'm going to number it from this end because I can visually see that if I go from this end, it's going to be a lower number on that OH than if I went on the other end. But if you didn't see that, you could number it from left to right and see that that number would be a 4. All right, and I can also see that if I go to the bottom route, it's going to be the same number because if I started here as 1, 2, this is still 3, 4, 5, 6. 6 is your longest carbon chain. And so the base name there is a hexane. But we have an alcohol, which means that we're going to drop the E and we're going to add OL. So we have a hexanol, OL. All right, and then we have to give the lowest number for the carbon that contains the OH, and that is a 3. So when we name 3-hexanol, we have named 6 of our carbons and our OH. We have not yet named these 2 carbons coming off of carbon number 3. And that is an ethyl group, and so you have to say this is a 3-ethyl 3-hexanol. All right, and if it said to oxidize it, and what would your functional group be? You would say you would get no reaction. It would still be a tertiary alcohol. You cannot oxidize a tertiary alcohol. All right, if you wanted the common names for these, we'll give both the common and the Upac name. All right, and so here is methyl-methyl ether. You don't say methyl-methyl ether, you say dimethyl ether. All right, and then this one, you have your methyl and you have your ethyl. All right, you must put it in alphabetical order, so it is an ethyl, methyl, ether. I'm not sure if I will take points off. I may take minimal points off if it's not in alphabetical order, but you should remember to put it in alphabetical order. All right, so now we're going to use the Upac method, longest carbon chain. All right, so for the first one, there's only 1, and so that would be methane. And off of your methane, we have a methyl with an oxygen. That is called methoxy. And so that is methoxy methane. All right, now you don't have to put the 1. If you put the 1, I'm not going to count it wrong. There's no such thing as a 2-methoxymethane since methane only has 1 carbon. Anything coming off of it is that carbon. All right, so here the longest carbon chain is 2, 1 and 2. So this is an ethane. And coming off of carbon number 1 is again a methyl with an oxygen. So that is a methoxy. And so that is a methoxyethane. There's no such thing as a 2-methoxyethane. It would always be a 1-methoxyethane, so you don't need to put it. But if you put the 1, I will not count off points. But for the previous ones where we had our 2-methoxypropane and our 1-methoxypropane, if you don't have the numbers, then the answer is wrong. So make sure that when in doubt, put the number, because I don't take off for putting the number when it's not needed. But if it is needed and you don't have it, you do not have a structure I can come up with. At least not 100%. It can be a guess. And note here that they give the answer not in alphabetical order, so that is wrong. It should be ethyl methyl ether. All right, aldehydes and ketones. So again, our aldehyde will have a a C double bond O with an H. All right, so I'm going to write up the simplest aldehyde, and I'm going to give the two names. So you need to know the common name for this simplest aldehyde. All right, so when you're naming an aldehyde, all right, so for aldehydes here, I'll put it, you drop the E and you add Al. That is the Upac name. For a ketone, you drop the E of the base name and then you add ONE for a ketone. So this one, you have one carbon, so that is methane. You drop the E and you add Al. This is methanol. No one calls this methanol. The group that you have for the aldehyde, this is called a formal group. All right, so just like you got methyl and ethyl and propyl, you have formal groups. So the formal group is a C double bond O to H. And so this is a form aldehyde. All right, and so you probably have heard of formaldehyde. If not, it's on the news a lot. They never call it methanol. They always call it formaldehyde. So you need to know the structure for formaldehyde. And on that same naming, if we have the formal group on a carboxylic acid, this is called formic acid. So here you have the formal group. So this is formic acid. Remember, when you're naming your carboxylic acids, you drop the E and you add ic acid. So this would be called methanoic acid. All right, but most people will call that formic acid. The other aldehyde and carboxylic acid that you will need to know is one that you already know, the carboxylic acid. This one has the acetyl group or the acetyl group. So now we have a CH3 C double bond O group. This is the acetyl group or the acetyl group. The acetyl or acetyl can be pronounced either way. And so you have, longest carbon chain is 2. You have you have ethanol. Do the acid next. So this is 2 carbons, ethane, drop the E, add Al. This is ethanol. All right, and so this is the acetyl group on this aldehyde, and so this is called acetaldehyde. So you have formaldehyde, you have acetaldehyde. All right, and when we go to its corresponding carboxylic acid, all right, so this is ethanoic acid. Longest carbon chain is 2. You drop the E and you add oic acid. This is ethanoic acid. You drop the E and you add oic acid. All right, and so, but no one calls this ethanoic acid. We have this one from first semester Gen Chem. This is acetic acid because it has the acetyl group on an acid. This is acetic acid. So everyone will call this acetic acid. All right, and then the ketone, we already did this one before, but the ketone, so if you look at the simplest ketone, the one that has methyls on each side of your ketone, you have the acetyl group. All right, and so it is a ketone, and so that is how it got its name, acetone. All right, so that is acetone. That is the acetyl group, ketone, acetone. All right. So these are the common names that you will need to know. You need to know formaldehyde, you need to know formic acid, you know acetaldehyde, you know acetic acid, you need to know acetone. Those are the common names that you will need to know. All right, here we have a formal group on an aromatic hydrocarbon. And so another name for benzaldehyde, you would not need to know the name of the benzaldehyde. You would need to recognize a aldehyde group and an aromatic hydrocarbon. But this would be a formal benzene. So if you were to name this, benzaldehyde is not the name I'm looking for. I'm looking to see if you know that the name of this group, C-double-bond-OH, is called the formal group, and it's coming off of a benzene ring. Just like if I had a CH3 up here, it would be methyl benzene. This is a formal benzene. All right, for the other ones, I would just have you recognize the functional groups. Aldehyde here, aromatic hydrocarbon here. Any benzene ring is an aromatic hydrocarbon. Make sure it has the circle in the middle of the six-membered ring. If there is not a circle, it is not an aromatic hydrocarbon. You got an alcohol as an OH, and you got your ether here. So this is your aldehyde. Here is your aromatic. Just leave it as aromatic, hydrocarbon, but aromatic. Here is your ether, and here's your alcohol. All right, here's your aromatic hydrocarbon. Here is your aldehyde. And here is your alkene. And you see that this is a special alkene. This one is a trans alkene, where one H is, they're on opposite sides. One's up, one's down. And so for those, you would just have to be able to recognize the different functional groups on the compounds. Oh, and when you write it in a condensed molecular formula and you write a CH3COOH, you need to know how to get 4 bonds to that carbon, how to get 2 bonds to every oxygen, how to get 1 bond to every hydrogen. And if it's a nitrogen in there, it has 3 bonds. If there's a halogen in there, it's always 1 bond. All right, so anytime you're doing this, carbon, 4 bonds. Nitrogen, 3 bonds. Oxygen, 2 bonds. Hydrogen, 1 bond. And a halogen, so whatever, fluorine, chlorine, bromine, iodine, also 1 bond. All right, so anytime you're writing a structure, if you don't have that, you don't follow this rule, then you have the wrong structure. So when they write a condensed molecular structure, CH3COOH, that means that this carbon is connected to 3 hydrogens. So that carbon is connected to 3 hydrogens, which is then connected to the next carbon. Now this carbon has to have 4 bonds. All carbons have to have 4 bonds. All oxygens have to have 2 bonds. And so if you write COOH just as it's written, well, you got your 2 bonds to oxygen, you got your 2 bonds to oxygen, you got 1 bond to hydrogen, except here you would only have 2 bonds to that carbon. So that is not the structure. When, of course, they list it as a carboxylic acid, you know that you're going to have a C double bonded to O and to OH. The only way that you can get 4 bonds to the carbon, 2 bonds to each oxygen, and 1 to the hydrogen is if you have it as a C double bond O to OH. That is the only way to get that to 4 bonds for carbon. All right, this is a condensed molecular formula, not to be confused with a molecular formula. If the choice was C2H4O2, all right, so now you're going to have a lot more choices to how you can write that structure. When it is written in a condensed molecular formula, CH3COOH, there is only one answer for that. If you write it as a molecular formula, many times there is more than one answer for that. All right, if we are doing CH3CHO, all right, again, you have to have the CH3 So you have to know that that means you have a C with 3 bonds to H, and then that is bonded to the next C, which is bonded to an H, and now it's bonded to an O. H cannot have another bond. H can only have one bond. This carbon only has 2 bonds. It has to have 4. O has to have 2. Perfect. Double bond O. All right. And so when you see an aldehyde is going to have an ending or a beginning of CHO. Another way you could write your carboxylic acid, it could end in CO2H. So if you ever see an RCO2H, that's the same as RCOOH. All right, so now we're going to make an ester. All right, when we make an ester, we're going to take a carboxylic acid. So any carboxylic acid, so R, then C double bond O to OH. R is any alkyl group, methyl, ethyl, propyl, isopropyl, whichever. All right, any carbon group. And then we're going to add to that an alcohol, any alcohol, methanol, ethanol, propanol, any alcohol. All right, and when we do this reaction, it requires a catalyst, an acid catalyst. And so over the arrow, I'm going to put H+. Anytime you do a reaction that forms an ester, it is called an esterification. So this is going to be esterification. All right, so if they say name this type of reaction that makes an ester, well, then the answer is it's an esterification. All right, in order to get the ester, we will take the OH from your carboxylic acid and the H from your alcohol, and we're going to lasso. So this, an esterification, is a condensation reaction. Anytime you're going to lasso something, that reaction is called a condensation reaction. You're going to get a small molecule. So you bring the parts together, and so you have your ester, your R to your C double bond O to your O to your R, plus you've got your water. So you have started with a carboxylic acid and an alcohol, and your product is now an ester and water. All right, so we don't care about the water in organic chemistry because there's no carbon. It's not an organic product. And so we have our carboxylic acid, our alcohol makes our ester. This is an esterification. Anytime you lasso a small molecule, and when you're lassoing, it's going to be water, HBr, HCl, are the usual lasso compounds. And so this is called a condensation reaction. All right, so you have water released. All right, so you're forming an ester. It is an esterification. All right, so now we're going to name our carboxylic acids and esters. So the rule for your carboxylic acids, you're going to drop the E, you're going to add oic acid. All right, so 2 is your longest carbon chain. Carbon number 1 is always the C double bond O. And so you have ethane, you drop the E, you add oic acid. And so you have ethanoic acid. Of course, no one calls it ethanoic acid. Everyone calls that acetic acid. All right, now if I put a methyl on both sides of that, CH3, C double bond O, and then an OCH3, now I have an ester. To name an ester, you name the group coming off of the oxygen first. Then you name the remaining part as a deprotonated carboxylic acid. And so this is a methyl. And when you take the H off of an acid here, so if we take the H off of this ethanoic acid, now it is a minus. And so this, we have it memorized from Gen Chem. This is our C2H3O2 minus. That was memorized as acetate. because we also know that ethanoic acid, no one calls it ethanoic acid, everyone calls it acetic acid. So in Gen Chem, we had our acetate, we added an H to it, and the 8 converts to ic acid. All right, so if you take the H off, your ic acid converts to 8. And so this is methyl acetate, or it is methyl. And so instead of ethanoic acid, it's ethanoate. You take the ic acid and you convert it to 8, ethanoate. So methyl acetate or methyl ethanoate for the name of your ester. So you always name the group coming off the O first, and then you name the remaining as a deprotonated carboxylic acid. That means it's going to end in 8. Your 8 goes to ic acid when you add an H. You remove an H off of an ic acid, it goes back to 8. All right, so here's some common names. We did the first two. All right, so your formic acid. All right, your formic acid comes from ants. So if you get stung by an ant, you have been injected with some formic acid. And so, of course, the Upac name is methanoic acid. Your acetic acid that we know from Gen Chem 1, where we had it memorized, and that is in vinegar. So a 5% solution of acetic acid is called vinegar. You can easily figure out the next two. So propionic acid is the same as propanoic acid. So very little difference in the common and the Upac name. Same with the 4-carbon one, butyric acid and butanoic acid. Okay, so that's 4 and that's 4. You do not need to know about the 5 and the 6. Valeric is a pentanoic acid, and caproic is hexanoic acid. You do not need to know those two. You have to know formic and acetic. Propionic and butyric may show up. Those are pretty simple. It's the same as propanoic, same as butanoic. But you will definitely need to know the formic and the acetic. Formic sounds nothing like methanoic. Acetic sounds nothing like ethanoic. So you will need to know the formic and the acetic, which also means you need to know the formal group and the acetyl group or the acetyl group. All right, now the compounds that contain nitrogen. First one we're going to start with is the amines. All right, and so when we talk about amines, we will have primary, secondary, tertiary amines. These are a different way to look at it than your alcohol. So if we're starting with ammonia, which is NH3, if we want a primary amine, we have to take off one of those H's and put an R group. So an R, NH2, is a primary amine. So one of the hydrogens was replaced with an organic alkyl group, so methyl, ethyl, propyl, whichever R group you pick. If you replace two of them, so get rid of two of those hydrogens, now there's one hydrogen left. And now you've got an R and an R. So if you have that, you have a secondary amine. So a secondary amine is when you replace two of the hydrogens with alkyl groups. If you replace all of your H's with R groups, so now you've got an N with 3 R groups, 3 carbon groups, rather than 3 hydrogens, now you have a tertiary amine. All right, so when you did your alcohol, it was about how many carbons are attached to the carbon containing the OH. When you're doing your amines, it is about how many carbons are attached directly to your nitrogen. So if you have just 1 carbon attached, it's primary. If you have 2 carbons attached, it's secondary. If you have 3 carbons attached, it's tertiary. All right, so claim to fame for your amines is they are the most basic organic functional group. So an amine most basic organic group. All right. So the most acidic is really easy because it's got acid in its name, the carboxylic acid. Most acidic organic group. All right, and so you can do a reaction, a simple acid-base reaction. So if we take methylamine, that means CH3 with an NH2. All right, so the methylamine, and you take acetic acid, you can do a simple acid-base reaction. So your nitrogen, the electron pairs on your nitrogen, will take the acidic hydrogen off of your carboxylic acid, and you will now have a CH3, and now you're going to have 3 H's on that end. And now that has a plus charge. And then you're going to have your acetate, your O minus, C double bond O, and then CH3. And so you started with methylamine and acetic acid. And now we know from Gen Chem 1, NH3 is ammonia, but NH4 plus was one of the memorized polyatomic ions. That is ammonium. And so when you have a positive nitrogen, you have an ammonium. Now this ammonium has a methyl on it. So this one is methyl ammonium. All right, so when you say ammonium, you know that you have a plus charge on your nitrogen. And then this one was memorized right from Gen Chem 1. This is your acetate. All right, so that is simply an acid-base reaction. Your amine is reacting as the base. The acid is reacting as the acid. So the base is a proton acceptor, and your acid is a proton donor. All right, so here you have your amines. You got your methylamine, dimethylamine, trimethylamine, ethylamine, piperidine. Piperidine. Anyway, that one is not that common in synthesis, but aniline is very common in synthesis. All right, before we talk about amides, I'm going to talk about solubilities. All right, so a lot of questions are going to be which one is more soluble in some solvent. All right, the general term here is like dissolves like. We did this first semester as well. And so when you have water as your solvent, and you want to know which one of these is more soluble. So which is more soluble in water? All right, so they'll give you a list. And so they'll say CH3, CH2, CH3, and they'll say CH3O, CH3, and then CH3, CH2, OH. All right, and so when you're looking at water, you have H, you have O, you have H. All right, and so like dissolves like. If you can find anything that has an OH, that is going to look very similar to your water. And of course, you have that, and that is your alcohol. So the most soluble is going to be the one that looks most like water. Least soluble is the one that looks the least like water. All right, so water has an oxygen. This one has an oxygen. This one does not have an oxygen. The least soluble is your CH3, CH2, CH3. All right, it doesn't have an O in it, so it is least like water. All right, and of course, this is going to have high boiling points because of hydrogen bonding. So remember your hydrogen bonding. So anything that has OH or NH is going to have hydrogen bonding. All right, and so if you have hydrogen bonding, then you have like dissolves like, something else that has hydrogen bonding is going to be more soluble. So remember that hydrogen bonding will increase your boiling point. So this will increase the boiling point. So I could ask the same question here. Instead of which one is more soluble in water, I could say, which one of these has the highest boiling point? And it's the one that has hydrogen bonding. And so you would still circle your ethanol. It's going to have the highest boiling point. And that is due to hydrogen bonding. So if you have hydrogen bonding, OH-NH, you're going to have a higher boiling point. All right, so amides is going to be a reaction. So we're going to have the same two compounds. I'm going to take my methylamine. I'm going to take my acetic acid. And I'm going to lasso water. So it's always the OH from your carboxylic acid, and then your NH. All right, and so the reason why the statement here says it's got to be a primary or secondary amine is because I have to lasso an NH with the OH. If I have a tertiary amine, I do not have an NH to lasso. All right, and so I'm going to do a lasso. That means I'm doing a condensation reaction. All right, and so my organic compound, CH3 to N to H, now that's connected to a C double bond O and CH3. And then the small molecule that comes out is water. So that is a condensation reaction. And so we see that we have an amide. And so we'll also see in the biochem chapter that we're going to have a lot of compounds that have an amine and an acid in it. And those are amino acids. So the most basic and then the most acidic. All right, so you have two choices. You can just simply do an acid-base reaction that we did in the previous slide, or you can do a condensation reaction and form your amide. Now, to name an amide, you have to name the group coming off of the nitrogen with a capital N. And so this is an capital N, and that is treated as a number, requires a dash after it, methyl. So we have an N-methyl. And then on the other side, C double bond O, we need the longest carbon chain, which is 2. Anytime you are naming an amide, you're going to drop the E, and you're going to add amide. All right, and so this is an ethane. I'm going to drop the E and add amide. And so this is an N-methyl ethanamide. Is how you would name your amide. And this amide, this nitrogen, is bonded to 2 other carbons. So this is a secondary amide. So when you start with a primary amine, you will get a secondary amide. If you started with a secondary amine, you would get a tertiary amide. If you started with a tertiary amine, you would get no reaction, no amide form. That is the end of the chapter. All right, so I want to go through probably the hardest questions, and they would be given a molecular formula, give the number of compounds. So my favorite one is a C4H10O. And if it's really hard, it will say, give all the structural isomers. Or if it's even harder, it'll say give all the isomers, structural or stereo. But on the test, it's going to be more like give the 7, they give you a number so you know how many you're looking for, give the 7 structural isomers. All right, so anytime I have a molecular formula and I want the isomers, I always start with the longest carbon chain. And so if I have 4 carbons, the longest carbon chain is going to be 4 carbons in a row. And then I have an O, and so I can put an OH here. And then when I fill in all my carbons, I'm filling them in because all carbons have to have 4 bonds. All right, and so I have my CH3, CH2, 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 and an OH. That is 10 hydrogens, 4 carbons, and the 1 oxygen. And so here is a structure, and so I need to name it. And again, when you name it, you want to number it closest to the group so that that group number is as small as possible. In this case, it is 1. So we have an alcohol. All right, this alcohol is connected to a CH connected to 1 other carbon, which means it is a primary alcohol. The name of this alcohol has 4 carbons, so that would be a butane. But I know that it's an alcohol, so I know I'm going to drop the E, and I'm going to add OL. So this is a butanol. All right, and so then again, I have to get the lowest number possible for the carbon that contains the OH, and that in this case is a 1. And so this is 1-butanol. All right, I could also ask for the common name. So give the 7 structural isomers, give the Upac name, give the common name. If it's an alcohol, label it primary, secondary, tertiary. All of these things can be asked on the same question. So this is the Upac name. The common name, this group is the butyl group. So this is butyl alcohol. I would prefer it to be called N-butyl alcohol, but butyl alcohol would be accepted. N-butyl alcohol is very clear that this is a straight chain alcohol. All right, so when we had our 4 carbons in a row, we see that we could have put it on the second carbon instead of the first or last carbon. All right, and so again, we have to have 4 bonds to carbon, so that's a CH3, that's a CH2, that's a CH, that's a CH3. You may want to write out all the bonds. If you cannot see that all those carbons have 4 bonds, you should write out every single bond to see that all those carbons have 4 bonds. The oxygen has 2 bonds. The hydrogens all have 1 bond. All right, so again, longest carbon chain, start at the end closest to the OH. You do that so that it has the lowest number, in this case is 2. And so here is your 2-butanol. So if there was any question on whether you needed the 1 for the 1-butanol, the answer is yes, because there is a 2-butanol. All right, so the 1 was definitely required, and the 2 here definitely required. If you just said butanol and butanol, no, these are not the same. All right, and so your group, now you have to know that when you have this one, all right, so your carbon connected to your OH here has 2 other carbons attached. So this is a secondary alcohol. And so, which is good because it's still a butyl group, and so it is a sec-butyl alcohol. Because that is the sec-butyl group. All right, so that's our 4 in a row. Now let's go, well, again, when I give this problem, many people will then put the OH here and then say, well, here's my 3 butanol, except that, of course, is wrong. This is 2-butanol. You must follow the rules, which are give the lowest numbers possible. So a lot of times on the test, I'll get the same compound multiple times, named incorrectly. Named correctly one time and named incorrectly every other time. If you're naming it correctly every time, you will just get the 7 different names. All right, so that's it for 4 in a row alcohol. So let's try 3 in a row alcohol. So if I put the carbon at the beginning or the end, then I would have 4 carbons in a row. So I have to put that carbon in the center, and then I can put my OH wherever I want. I pick here. All right, so then I have all of my carbons have to have 4 bonds. I fill in with H's, and then when I add up my 3, my 1, my 2, and my 1, yes, I still have my 10 hydrogens. All of these are C4H10O. All right, so then my lowest number has to be on the OH. So 1, 2, 3 is my longest carbon chain. All right, so that is a propane. I know it's an alcohol, so I'm dropping the E and adding OL. This is propanol. And so the lowest number that the OH is attached to is a 1. This is a 1 propanol. When I name 1 propanol, I have named 3 carbons and the OH. I have not yet named this CH3 coming off of carbon 2. This is then a 2-methyl 1 propanol. All right, and I also see that my OH is connected to a CH2 connected to 1 other carbon group. This is a primary alcohol. All right, and so when I see this, I see that I have a CH3 connected to a CH connected to another CH3. Anytime you have a ending that is a C with 2 methyls attached to it. If there were 3 carbons, that would be the isopropyl. If there are 4 carbons, which is what we have here, this is the isobutyl alcohol. So there is your isobutyl alcohol. All right, let's go to our 3 carbons in a row and put in the OH again. So 3 carbons in a row, the 4th one in the center. If I put my OH here, longest carbon chain is 3. Lowest number for the OH is 2. I still have a 2 propanol. All right, but that just takes care of 3 of my carbons in my OH. There is another carbon. Off of carbon 2, I have a methyl. So this is a 2-methyl. 2-propanol. All right, and so when I look at the carbon attached to the OH, I see that that carbon is attached to 3 other carbons and no hydrogens. This is a tertiary alcohol, which is the name of the group, and that is a tertiary butyl alcohol. So you note that the secondary alcohol is called secondary butyl alcohol or sec-butyl alcohol. The tertiary alcohol with 4 carbons is the tertiary butyl alcohol or T-butyl alcohol or tert-butyl alcohol. All right, if you think that coming off the bottom would be different, so we came off the one on the right, we came off the one in the middle. What about the one on the bottom? Again, if you put the OH here, as long as you are following the Upac rules in naming, you will see that your longest carbon chain, lowest number for the OH is 1, 2, and 3. And so that is a propanol. And then off of carbon 2, you have a methyl. And so you have a 2-methyl 1-propanol, and we see that we already named 2-methyl 1-propanol. All right, so as long as you are consistent in your naming, following the rules, you're only going to get 7 different names. You might draw 20 different compounds, but they're not different. Only 7 of them are different. Only 7 of them will have different names. All right, so that is it for our alcohols. So now we're going to go to our ethers. And so now we're going to have an oxygen between carbons. So since we have 4 carbons, we can start with 2 carbons on each side of your O. So when we put in our 4 bonds to carbon, we see that we have a C4H10O, and that is of course a 2. All right, so your 4 bonds to every carbon. And so this is an ethyl and an ethyl and an ether. No one says ethyl, ethyl, ether. This is diethyl ether. Or longest carbon chain is 2. That would be an ethane. And off of carbon number 1, we have a ethyl with an oxygen. So that is ethoxy. Now you can put the 1 there, and that would be fine. 1 is not needed. Ethoxyethane is the name. This is not an alcohol, so you don't do primary, secondary, tertiary. So that is it. All right, but we have 4 carbons, so we didn't have to do 2 and 2. We could have put 1 on one side, and we could have put 3 on the other side. And now we have a C4H10O. Now the name of that, well, this is methyl. And this is propyl, or N-propyl, and that is ether. So methyl propyl ether, or methyl N-propyl ether. The Upac name, 1, 2, 3, is the longest carbon chain, so that is your propane. And off of carbon number 1, we have a methyl with an oxygen, so we have a 1-methoxy. So we have a 1-methoxy propane. All right. So again, this time I didn't say the 1 was optional because it's not. You have to have the 1 here. So 1-methoxypropane. If you just said methoxypropane, well, I wouldn't know if you wanted that one or if you wanted this one. Where you have 1, 2, 3 is your longest carbon chain for your propane. But off of carbon number 2, you have a methoxy. So this is 2-methoxy propane. So if there is such a thing as a 2, then the 1 has to be put when it is 1. All right, and then your Upac name. So here is where your iso, sec, and tertiary, those are used for alphabetical order. Your dis, tris, and tetras are not used for alphabetical order. So here you've got methyl, and here you have isopropyl. All right, and so I would not count it wrong if you named it methyl isopropyl ether, but it should be alphabetical order with the I first, isopropyl, then methyl, then ether. So the other one, methyl N-propyl ether, so whether you went with the N or the P, it always comes after M. So it has to be methyl and then propyl, or methyl and then N-propyl ether. Here, if you said isopropyl methyl ether, that's the correct way to do it. But if you were doing alphabetical order of methyl versus propyl, and so you said methyl isopropyl ether, I would not count that wrong. So those are the hardest questions to do on the test. All right, so if I took my isobutyl alcohol, and I added my let's see, CH2, CH3, and I added a carboxylic acid, and I said that this is an acid. All right, you would have to recognize this as a carboxylic acid with your alcohol, and you would have to know that this is going to take the OH from your carboxylic acid and your H from your alcohol, and it's going to then bring those things together. And then you will have to name, plus water, you'll have to name the organic compound. All right, so this is an esterification. We have made an ester. So again, you have to name the group coming off of the oxygen. So this can be done so you know that the name of this group, we just did it right up above. This is your isobutyl group. All right, and so then you have to name the rest as a deprotonated carboxylic acid, longest carbon chain, but this C double bond O has to be carbon number 1. And so you have a pentane, but it is a pentanoic acid, but we are deprotonating it, and so our ic acid is gone, and that is then an 8, and so this is a pentanoate. When you get rid of your ic acid and you add 8, all right, but off of carbon 4, you have a methyl, and so you have then a 4-methyl pentanoate. So you have isobutyl, separate word, 4-methyl pentanoate. So this one is 2 words. All right, so that one is the hardest one to name. If we have a methylbenzene and we add Br2, normally this will have a catalyst, FeBr3. All right, so what you have to know here is, I might say you're going to get 3 products. All right, and then I'll have you name the 3 products. All right, so what you have to know about this is that it is going to be an aromatic hydrocarbon, and you're going to do a substitution reaction. So anytime you have an aromatic hydrocarbon, you're going to lasso, in this case, an HBr. And the reason why I said there's going to be 3 products is because you can lasso one of these 2, and that would give the same product. That would be the ortho product. You could lasso one of these 2. That would give the same product. That would give the meta product. Or you could lasso this one and get the para product. And so when you're doing these, you have your Br, Br, you have your Br, Br, you have your Br, Br. All right, so you can lasso HBr here. And one of your products is going to be your methyl with the Br here. All right, you can do it here. And so you could then put the Br in the meta position. Or you can do it here, and this is your 3 products. And those 3 products are ortho, meta, and para. And when you take organic chemistry, you will find that when you do this reaction, you're going to get your major products are going to be ortho and para, and the minor product is going to be the meta, but we don't need to know that for this one. What we do need to know is that we get substituted products, and we have to be able to name them. All right, and so this is a bromomethylbenzene. All right, and so you can use numbers and call it 1-bromo, 2-methylbenzene. The numbers 1 and 2 are always going to be 1 and 2 no matter which way you number it. But since it doesn't matter, we'll put alphabetically first this lowest number. All right, and so, but instead of 1, 2, you could just call this one an ortho, or simply an O, ortho bromomethylbenzene, or simply O, bromomethylbenzene. And then this one would be a 1 bromo 3 methyl benzene. And this one would be a 1 bromo 4 methyl. But of course, this one could be meta, and this one could be para. So you can use the numbers 1 and 2 or ortho. You can use the numbers 1 and 3 or meta. You can use the numbers 1 and 4 or para. Ortho, meta, para only works if you have 2 groups on a benzene ring. All right, we will continue doing problems the rest of this week on chapter 23.